Now let us discuss the third problem of assignment 8. If you remember, when I took a Google Meet class with you, I told you that this question was incomplete. It was incomplete because the consumption function had not been specified. So I have corrected that error of mine. So we are looking at a 3-sector national income determination model where your I is given as your I is, where your I is autonomous investment, which is equal to 50 units. Your G, government expenditure, is also autonomous, hence represented by G naught, which is 25 units. Your consumption function is 25 plus 0.75 Y, where Y is your national income. So here, this consumption function is additional information. It was missing in the original assignment that I had uploaded in Moodle. So please do make this necessary correction. So when is our national income model in equilibrium? When the aggregate supply is equal to aggregate demand. It is only at equilibrium that your aggregate supply will be equal to aggregate demand. And if you remember your Keynesian economics, what he says is there is no automatic tendency in an economy for the aggregate supply to be equal to aggregate demand, especially at the full employment equilibrium. If this equilibrium is achieved at full employment, then it is just by chance. So our condition for equilibrium is aggregate supply equals to aggregate demand. Now, what is aggregate supply? One second. Aggregate supply is nothing but the total output that has been produced in the economy, which I am representing as Y. What is aggregate demand? Aggregate demand is demand for consumption expenditure plus investment expenditure plus net government expenditure, since this is a 3-sector model. Had it been a 4-sector model, we would have had the foreign sector or the trade sector as well. So first let me formulate the aggregate demand equation. Remember, I am supposed to solve this and find the equilibrium national income in terms of the graph, which is why I am taking this method. So instead of C, I am going to write the function 25 plus, that is a specific functional form, 25 plus 0.75y plus I, which will be autonomous investment I naught, which is 50, plus G, and we know that G is equal to G naught, that is autonomous government expenditure, which is 25. So my aggregate demand equation becomes equal to 100 plus 0.75y. This is, I'm going to name this equation 1. This is my aggregate demand function. Now, you can solve this aggregate demand equals to aggregate supply mathematically or algebraically by putting aggregate supply equals to aggregate demand. So aggregate supply is Y, aggregate demand is 100 plus 0.75y. So taking Y to the left hand side, I'm left with, I've just done two steps together. That is, I took 0.75y to the left hand side of the equal to, so it became negative 0.75y, and I've also taken y common, which is why I've got y in brackets 1 minus 0.75, which is equal to 100. Okay, so that is 0.25y is equal to 100, and y is equal to 100 by 0.25. You guys have a calculator, otherwise since 25 4s are 100 and another 2 zeros, so this is my equilibrium national income. This part of the solution, which I just did, is the algebraic solution, right? Do you remember how it is done graphically? Well, graphically, we have to plot the aggregate demand curve. Graphically, what we have to do is we have to plot the aggregate demand curve, which will be equal to C plus I plus G, and we have to see where it intersects with the aggregate supply curve. So if you have to do this, you need to remember from your macroeconomics lectures the diagram of the national income equilibrium model. So once again, over here I'm going to write the aggregate demand equation. It was 100 plus 0.75y, right? Let me just figure out the 2 points that I want to plot. So y, or national income, is on the x-axis, aggregate demand is on my y-axis, because that is on the left hand side of equal to sign. First, let me assume y equal to 0. So when y equal to 0, aggregate demand equals to 100 plus 0. So that's my first point, the coordinates 0, 100, and I need to find one more point. Remember, you can find coordinates to any point. Lots of earlier examples where we were plotting straight lines, what we did was we assumed that the variable on the y-axis is equal to 0, and then we figured out what the answer was. But here what I'm going to do, I think it'll be easier for me if I assume y to be 100. So when y is equal to 100, my aggregate demand is equal to 100 plus 0.75 into 100, which is 100 plus 75, which is 175. Now to plot this line. Okay. Okay, let's just assume that I had drawn a perfectly straight line coinciding with the grid line. The horizontal line is a bit better. So on my x-axis, I am drawing y, or the national income. On my y-axis, I am drawing variables like aggregate demand or national output, which is again y. So now 25, 50, 75, 100, that's 100, 125, 150, 175, 200, 225, 250, 275, 300, 325, 350, 375, 400, and so on. And I'm going to take the same measurement on the y-axis as well. So that's 50, 25, 25, 50, 75, 100, and 125, 150, 175, 200, 225, 250, 275, 300, 325, 50, 375, 400, and so on. Let me plot my aggregate demand curve. When y is equal to 0, aggregate demand is 100. Okay, let me change the color to say dark blue. So this is my first point, 0, 100. And second point is when y is equal to 100, my aggregate demand curve was 175. I haven't written it here, but I have calculated that. When it's 100, that's the point. So that's the point over here, right? So this is my aggregate demand curve, which is equal to, the equation was 100 plus 0.75 y, right? Now, do you remember what the aggregate supply curve looked like? It was a 45-degree line from origin. A 45-degree line is such that, remember, I'm taking national income or aggregate supply on the left hand x-axis and aggregate demand or national output on the y-axis. So the 45-degree line would be something like joining, if I were to join, right, 200, 300, and 400, right? Okay, let me just use another color for that. Something different. Orange color. Oh, wait. Okay, you guys will find it much simpler to do. This is my 45-degree line, which represents the aggregate supply curve, or at least the points, all those points along this 45-degree line is where the aggregate supply is equal to aggregate demand, right? Which is why to find national income equilibrium, we try and locate the point where the aggregate demand curve intersects the y-axis. So this is my y star, or equilibrium national income level, which is equal to 400. The question asks you to solve for this national income equilibrium graphically. But since you do not get graph papers and you have to draw with a pen and paper, or rather a pencil and paper, or normal ruled pages, it is always wiser to solve for the national income equilibrium level beforehand using the algebraic function aggregate supply equals to aggregate demand. So y is equal to 100 plus 0.75y, and you know that it's going to be equal to 400. So I actually use that information to correctly plot and get the intersection point over here. Once again, I'm winding up this solution by reminding you that if you plot it properly with a ruler and a pencil neatly on a paper, you will get this correctly. Okay, I hope there are no more doubts.